All right, so we're going to look at systems of linear equations. All right, these are some of the more I like them. I think these questions are a little bit more interesting than some of the other stuff that shows up. Uh, what we have here is I've got three separate problems here. We'll have to take them one at a time, obviously, but each of these are what they call a system of linear equations. Basically, you've got two lines that you're thinking of as one problem. So you know how there's several solutions to this top equation? Like if I plug in 3 for x, I'm going to get 0 back for y. So what that means is that 3 comma 0 is a solution to that equation. And down here, this has multiple solutions as well. If I plug in 2 for x, so 2 times 1/2 is equal to 1, 1 plus 1, that's equal to 2. So 2 comma 2 is a solution. But when you're given a system of linear equations like this, what you're asking, what you're trying to find out is where do the two lines intersect? What's the 1x comma y pair that satisfies both equations at the same time? That's what we're looking at. And there's going to be several ways that you can go about solving these, but one of the most primitive or simplest, the easiest to start with is simply graphing them, all right? You can't always do this, but you can, you can give it a shot. All right, so I'll assume you don't have nice graph paper like that at home. But if you do, it sure does make your life a lot easier. What we're going to do is we're just going to graph these two lines on the same coordinate grid and look for where they intersect. Okay? Oh, this graph paper is, there we go. That side looks a lot better. So it helps if you have two different colors as well, like one for one line and another color for another line. So what I'm going to do here is start off by drawing an XY coordinate grid somewhere in the graph. Doesn't really matter where. All right, so I've defined my origin. There's 0, 0. And what I'm going to do is start off by graphing this y equals 3x minus 9. So I know it's going to start off 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Way down here. All right. And it's going to be going, my slope is 3, so I'm going to go up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And I don't know how far I need to go, so let me go ahead and graph my 1/2 x plus 1. So this one's going to start off at positive 1, and my slope is 1/2, so it's up 1 over 2. All right, so it looks like they're going to cross in this neighborhood somewhere. Up 1 over 2, up 1 over 2. And then on my penciled one, I need to go one more set. So up 3 over 1. 1, 2, 3 over 1. And that looks like it right there. That coordinate, whatever that ordered pair is, that's going to be the spot where my solution is. All right, we just need those coordinates. So it's on the x-axis. It's 1, 2, 3, 4 over, and then 3 up. That's my solution, is 4 for x and 3 for y. Because that's the spot where the two lines intersect. All right, there we go. And I can go ahead and complete my graphs here. Cool. Now what you want to do is once you find your answers, you actually want to plug them into the equation to make sure to check your solutions. So what I'm going to do is plug in 4 for x on both of these and 3 for y, just to make sure that it satisfies each equation. So 3 times 4 is 12. 12 minus 9, that does give me a 3 back for my y value. And then I'll do 4 for x. 4 times 1/2, that's equal to 2. And then 2 plus 1, and that does equal a 3 for y. Very good. Not too bad. And I'll go ahead and solve one more over here. All right. Let's do this. We'll do this in red here. Okay. And we'll go that way as well. All right, so my first line is negative x. That's a plus 5 there. Y equals negative x. How should I do this? Yeah, I'll do it like that. All right, so starting off at positive 5 on my y-axis. 1, 2, 3, 4, 5. My slope is going to be negative 1. So down 1 over 1. Down 1 over 1. Down 1 over 1. And so on and so forth. Not sure how far I need to go. This one, my slope is, or sorry, my y-intercept, it's not written here, but there's a plus 0 there. So I'm going to start off at 0, and my slope is negative 2. So it's down 2 and over 1. Down 2 and over 1. And these lines are not going to intersect over here. Looks like they're going to intersect in the top left-hand corner somewhere. So continue the pattern. Up 2 over 1. Up 2 over 1. Up 2 over 1. And you kind of have to judge for yourself where these two things are going to cross eventually. Or you can just keep plotting points and hope for the best. Yeah, that should do it. It looks like this one's going to eventually run into it. And then for the red one, I got to draw some more points. Up 1 over 1, up 1 over 1, up 1 over 1, and I guessed it, up 1 over 1. That spot right there, that's where they intersect. And then what I need is the coordinates for that point. All right, so it's 1, 2, 3, 4, 5. 5 units to the left. So that's a negative 5 for my x. And then count up here. All right, I guess I'll do it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units high. So negative 5 comma 10. And then, of course, you want to plug that back in and actually make sure it works. Negative 2 times negative 5 for x. And yes, that does give me 10 back for my y value. And then negative 5 for x. So it's negative 5, which makes it positive 5. And then positive 5 plus 5 is equal to 10. There you go. They intersect.